Hello everyone. So I'll be attending my first LeetCode hard problem. I've solved some problems from the binary search playlist from the Striver A to Z series, and yeah, I found it a little too overwhelming at first when I was solving this BS on answers, right? The last two problems I solved was not by myself. I had to see the solutions, and a big shout out to mm, our boy Striver for making this amazing playlist where the every answers are well uh, organized, and just it is perfect. I'll be solving the first problem from here, that is split array largest sum. So I think it is mostly like book allocation problem, but I wasn't able to solve this book allocation problem. I've also tagged it as a very tough one. So let's start. So given an array integers nums and split nums into k non-empty subsets of the largest sum of minus split in the minimum largest sum of the split is 7 to 5 to the k equals to 2. It is 18. Uh, how is it 18? So therefore best to split into the best way to split is 7 to 5. 7 to 5 from 8, 10, 8. And there is something where to extend. Right. So it is 18, right? And 7 here, 9, 14. So 14 here, and the maximum value is 18, right? So 18 will get returned. So yeah, it is like book allocation problem, but I'm not sure if it is the same or not. But I wasn't as I've already said that I wasn't able to solve that problem, and it I was super overwhelmed by the solution. It was just crazy how the Striver went into the solution. But yeah, mm, he just defined it so well. Let's try to uh, observe something with the largest sum. So 1 2 3 4 5 k equals to 2, and it is 9 because 5 and 4 is there, so that will be 9, and 1 2 3 will just lead to 6, which is basically less than 5 and 4, that is 9. So alright, so I'll be needing this to uh, test cases, but I'm not sure if both of them are enough for the test case. Also have 10 to the power 6, and here it is 10 to the power 3, so 10 to the power 3, 10 to the power 9, so it won't overflow, right? Yeah, so it won't overflow. Also k is given as 1. The k will be from 1 to minimum of 50 nums length. Either it will be less than either it will be whichever is the smallest. So maximum it can go up to 50, right? K, right? And if not, then it should be less than the nums length. So we don't have to check, right? So basically we don't have to check whether uh, whether k is greater than nums dot length, because every time it will be basically min of 50 and nums length. So minimum array, is it so? Wait a minute. Nums dot length it is said, right? So yeah, so it will always be less than, yeah, it will always be less than. So there can be a situation where the k would be 5, and there will be 5 elements like this, and the uh, then the greatest element will be returned, right? So like it is 10 here, so 10 will be returned. That is one case. So mm, right? So I'll just think for a minute about the best possible ways to approach this problem. So this is the classic problem where we have to minimize the maximum. So also we'll have to check if it is in the binary, if the binary search is on the answers, right? Or not answers, like in this. No, it isn't. So it is 18, right? So you have to obviously how dumb of that. So we'll have to just uh, sum it. We'll just sum it up, and then whichever has the lowest maximum, we'll just return it, right? So how will I just do that? Okay. First of all, it is said that there are four ways to split numbers into two sub. There are four ways to split nums into two sub arrays, right? So let's try to figure out what are the four ways first. So first of all, when it is 7, then it will be 2, 5, 10, and 8, right? So observations, right? And first of all, when 7 will be there, then it will be 2, let's say 2, 5, 10, and 8, right? When this is the case, it will be just, the first one would be just 7. Wait a minute. So first one would be just 7, and the maximum element here is uh, minimize the maximum, right? The concept is tricky, a little bit tricky, but we cannot take 7, right? It is said that minimize the maximum subarray length, subarray largest sum, right? Split array largest sum. So 10 and 8, 18, and 18, 5, 23, 25, it would be 25. So max it will be 25, right? For when it will be 2, and if it is 5, so the max would be 23, right? Did I do it right? Yes. So it will be 23, right? When 2 and 5 will be included, then it will be 18. And I guess this is the answer they gave, right? Because it is the minimum maximum largest sum, right? And lastly, it can also be like 10, and it will be 8. So 7, 9, 14, and 24 it is. So this would be just 24, right? So that is the thing, and this will only be returned, right? This is the one, this is just the one that will be returned. We'll just need to do it so that it can be returned. But how can we, right? That is the main question. So first of all, we cannot short it, right? Shorting would it is said that we have to take a sub array, so shorting won't do anything, right? So if you could just short it, then it would just be a little easier, I think. And then we'd know that the first two the first n minus 1 element will be the largest sum, but that won't do anything here because we are just said to take the sub array, so you cannot change anything in the array. First observation is that if it is not like that, we have to just edit, we cannot edit the array. So We'll just think. So if k equals to 2, right? So for a basic case, uh, let's try to think something. Hmm, quite a hard problem. So the minimum number, so the minimum element that needs to be satisfied, right? So the minimum element that you have to have so that you can break the array into two particular sub arrays would be something like, let's say you have 7, right? And the other array would be 2, 5, 10, 8. Hmm. So let's say we have an array like 1, 2, 3, 4, 5 for the second example, right? So if we choose 1 here as the minimum element, right? So if it is the minimum element, like if it is 1, and every time we'll try to assign less than less than equals to 1, if we try to do it, then what will be the case? It won't happen, right? So minimum, we have to start from 5, right? The greatest element in the array, the max of the array, we need to start from there. Because let's say we have this particular array 1 2 3 4 and 5. So let's say there are the k is 5, right? So let's think it like that. So k equals to 5, and this is the array we have. So the problem here is, if we have k equals to 5, we know for sure that uh, particularly the particular array would be divided into 5 parts, right? And k is 5 and the length of the array is also 5. In that case, the maximum of the array will be just returned, right? Yeah, so we have to choose the minimum boundary to that is we have to choose the maximum element, so that we can start from there. Like if it is 1, so we can assign 1, uh, the first sub array will be 1, right? And the second sub array cannot be 2, right? Because we have chosen 1 as the minimum boundary to it. So we cannot have 1 as a minimum boundary. Will have to choose 5 as the minimum boundary, that is the maximum element in the array. So here in this case we'll have to choose 10. So we can just create a function or what do you call it, method to just uh, find the greatest element in the array. That is done, and at max, let's say if k equals to 1, right? At max, the array can have uh, the, the k minimum will be 1, right? It will have to be 1, right? um, yes, so the k will have to be 1. So if the k is 1, so therefore the array will be divided into only one particular array, and that is, we have to return the total sum of it, right? We'll just have to return the total sum of it. Not Yeah, it will be just the total sum of it, right? So so we have just figured out the answer space, right? So the minimum answer to a particular problem can range from the lowest element in the array, sorry, highest element in the array, right, to basically the sum of the array, sum of the nums. The answer would range between these two, right? Either it can start, either it can be highest, or it can also be sum, and it can also be in the mid, right? So basically, the highest and sum of the numbers will be included, right? So for two cases we just figured it out when the num's length, first of all, when the num's length is uh, just let me write it. So if the num's length is equals to k, then return the maximum element. And uh, if nums dot length, if k equals to 1, right, then return the sum of all the elements. These are the basic requirements, right? So these are the two edge case. I'm just fumbling, right? These are the two edge cases we have figured it out. Now I'll have to, and we're very sure that the particular answer would be between these two elements, right? Now we'll have to figure out. Oh, all right. So um, now how will I divide it, right? What is the logic? How will I divide it? Um, so we are for sure that particular the highest element and the sum of all the elements, the whole thing will be in the increasing order, right? So for example, the highest element in this particular array is 5, right? So if it is 5, then let me write it. So highest element here is 5 less than equals to, sum here is basically 5 4 9 uh, 9 and there you have 6, right? Yes, so 15 is there. So obviously this is a this is in increasing order, right? 5 to 15, right? This is in increasing order, so we can use binary search, what I'm saying, binary search, right? There how you figure it out. Right, so when we'll have 5, right, so we know for sure that then k would be the maximum, and when it will be 15, then the k would be just the k would be just 1, right? So let's say if k is in the middle, right, there is this example where it is 2, right? So let's try to first visualize if what is the brute force approach, though I've figured out the optimal first, but I think brute force approach would help me to help me in some way. So first 5 less than equals to 15 is there. So let's say if it is 5 and 5, let's start from 5, and when it is 5, the k would just, then we'll just go from here 1. So the first sub array is made, so k would be 1, 2 minus 1, so k would be 1, and then 2, and we know for sure that 2 is done, right? So if 2 is done, we cannot go to 3. We are sure that there are more elements, right? So what should we do then? Like, if the array contains greater than, if the array will have greater than k sub arrays, when we have a minimum sum, right, what should we do? We try to increase the sum, right? Because if we don't increase the sum, we have to increase the sum, right, to search for greater maximum sum, right? So if it is 2, not 2, sorry, if it is if the minimum number of arrays when the sum is like 5 or any element between this, uh, let's try to figure it out again. So if we have this k equals to 2, right, and we'll try to figure out and we have something greater than 2, while our minimum sum is 5. So this is 5, and we have gotten uh, 2, and when it is 5, the the temp k will be 5, right? uh, let's say we have this variable here to check whether this 5 guys so this 5 elements, how many of the arrays it can be divided into, right? So that let's say that is k temp, so it will obviously come as 5, right? That is greater than equals to 2. Then we'll try to figure out any more largest sum that is there, because we need to exactly divide the array in two halves, not just greater than that, right? So we'll have to figure out something that would make us to uh, that will make us divide the array in exactly k equals to 2, not less than that or not greater than that, right? So this is on another observations, is that we need to exactly divide the array in k halves, k, yeah, in k parts, right? uh, right, and not more than that. I think it would help me. So mm, though it is given, it is exactly given, but I think uh, I'm trying to visualize a bit. Yeah, so if it is that, then let's say we have any we have already divided the particular array into more than k parts, right? So if temp k greater than k, then we know for sure that we'll have to increase the sum, right? The required sum. I'm just not telling you what are the variables. So I'm thinking of this is the required sum, right? We'll just trying to figure out that whether the elements are in this range or not. So let's say this is just the required sum. We're just trying to find out which required sum is the actual answer to it. Sorry. So yeah, so this just increase the required sum, right? And also you need to check, also there is this thing. So let's say if we have um what if there are two elements, if there are two sub arrays, right? So for example, for let's say for when there is this let's take a value like 3 4 5 6 6 is there, 9 5 6 7 8 9 9. So let's say there is also obviously it will be 9 only. So let's say we have 10, right? So let's say we have 10. We cannot have 10, then it would just oh hi we oh also yes, right, we can have 10. So let's say we have this value 10, right? And now it will start from here, and we'll just go till this end, and just start from here 1 and then 3 and 6 and 10, and then we'll start to add 5, it will be 15, that is greater than 10, right? So we cannot take uh, 5 in it. So first part of the array would be 1 2 3 4, and then the next part would be containing 5. So this will contain 4 5 6 7 8 9 10 10, right? So what will we do when we'll have exactly two elements? What should we do? We should figure out what we are trying to do is we are trying to minimize the number, right? So we are trying to minimize the maximum possible sum. So here we are finding that 4 3 2 1 is there, and this number 4 5 6 7 8 9 10. So this is just 10, right? So we're just trying to see that whether when the maximum possible sum that can have is it is 10, right? So is there any number less than that that can we minimize the 10? Is that that is the question, right? Can we minimize the 10? It is all right. We are just having two arrays when the minimum required sum is 10. But can we minimize it and expect the array to be divided into two exactly equal halves? Right, I have just understood the problem now. So if it is, if the problem is like that, uh, if the question is that, then we just decrement this thing, right? So we just decrement this. So else else if, right, else if temp less than k, not less than, it will be equal to k, then the required sum, then just decrement the required sum, right? Decrement the required sum. Am I right? I am right. Right. So yeah. Okay. The last case is when the k will be less than 1, right? When the k will be less than the actual, when the particular k would be just less than the temp k, sorry, the temp k will be less than the actual k, right? When this scenario comes, oh my net, oh my internet is gone, oh my god, I'll have to bring my, oh my god, I'll have to bring my phone to connect it through hotspot now, but I'll wait a few minutes. I'll try to code it up because it will take some time. I hope the internet comes by then. Okay, where was I? So let's say if we have k less than, let's say the temp k is less than k. So for example, uh, the temp k, we have successfully divided the array into one part, right? If that is the scene, right? So we know for sure that the number is less than equals to k, right? And we have to have a particular required sum that can exactly divide our array into two parts, and that is only possible when we have just minimized the required sum, if I'm able to make you understand that fact. So uh, let's say we have something like 15, right? And when it is 15, we'll have all the elements here, right? So if it is all the elements here, and then the k will be 1, right? So we are for sure that there must be some value that is always less than 15 when the array will be perfectly divided into two parts, right? So if it is the case when our temp k, like in this 15 case, the temp k would be 1, is less than, is basically less than k, right? I'll just write it, less than k, right? If it is less than k, then decrement, then yes, just decrement the required sum, because we are for sure that our value, our array has some elements in it. There is a particular required sum that will make us just divide the array into k parts, right? And if uh, we can just make it a little bit prettier by understanding what is happening here. So if temp k greater than k, then increase the required sum, and if it is not the case, right, we are for sure that it will just be less than equals to k, right? So we don't need this because we have just written this part. So less than equals to k, and we are for sure that if temp greater than k is not there, then this will be the possible thing. If the if condition is not matched here, then this will always be executed, right? So we don't need to specify this, we can just delete this if part, and we'll know that else then decrement the required sum, and I think we are good to go. Yep. And basically what we have written is basically binary search only, but the main thing is if it is linear search, right? If it is linear search and we're trying to figure out the exact required sum number, then we'll just start from the first, right? We'll just have this for loop, and we'll start from 5 here, and we'll go till 15, and in the meantime, whenever we find something that is equal to k, time k equals to k, then we are for sure that that will be the number, right? Because let's say we have 8, right? For this example, the 9 is the answer, and if we'll have 8, then obviously it won't be the answer, right? So let's say 2 3 and 6, right? And it will be 10. Obviously it is, therefore uh, it will be more than that 8, right? We cannot have that. So this first 3 elements will be first array. K will now be 1, and 4 and 5 would be what do you say, 9, and 9 would be greater than 8, so 4 will be stored as second array and third array, right? So k, temp k greater than k, so we'll just increase, and it will be 9, and whenever the 9 is hit, right, so we know for sure that the array will be divided into actually 2 equal halves, and then we can just return the sum, right? But yes, the complexity here is n, because it can go up to, so for this big O solution, for the linear solution, for the brute force solution, the complexity can go up to big O of max minus max to sum, right? So sum minus max, right? So right, yes, so it can go up to sum minus max. The maximum complexity can be going from max to sum, so sum minus max would be just fine. So this is big O of big O of n solution, and we can just minimize it. We can make it big O of log n log sum minus max. We can make it big O of log sum minus max, because we are for sure that 5 less than equals to 15 is basically whatever the elements in between are in ascending order, and you can just binary sort it, and we have just figured it out. And lastly, what should we return? That is the case. So we need to figure out. So binary search has this property, right? So this property is huge, and I think that kind of help us to help us to go somewhere, right? To figure out something. So first of all, there is a thing like opposite polarity in binary search. So if the first low will start from a position where we are sure that it might not be the actual solution, then it will go after the binary search, then it will go to somewhere, some position where at last it is the solution, right? Like if it is not the solution, when it will start, if it is not the solution, it is not a probable solution, then it will go at that position where it is a solution, right? That is the thing here. So for example, if we have that value 1 here, right, the 5 here, so we are sure that it is not in the solution, right? It is in the solution, right? It is in the solution. I don't think it is the right way. Let's try to figure it out. So at last we'll just I think dry run until we find out which we need to return. I think that is how I can get a normal view of what is happening once. So it will be starting from 5 less than equals to 15, and first time it will start 20 by 2 set, so it will be 10. So we'll check for 10. So when it is 10, 1 2 3, so that will be 6, and for 10, so 1, and 5 won't be eliminated, so 5 won't be considered, so it will be perfectly 2, right? So if it is perfectly 2, we want to find something lesser than that also, right? So we will decrement it, 5 to 9, so 5 and 9 would be 14, 7. So 7, when it is 7, so 3 4 5 6, so first 3 elements will contain 1, will be temp k will increase to 1, then 4 and 5 will be 9, that is greater than that, so 3 elements which is greater, so we'll increase the required sum. So 6 to 9 would be the next case. 6 to 9, when it is 6 to 9, it is 15, so 7, 15, right? Yes, so it is 15. It is not the case, I guess. What I'm doing, if it is not 5, we have just sorry, we were checking for 16, right? We didn't, we were checking for 9 6 and 5, 9 6 15, 15 7, we were checking for 7. It didn't happen like that, so 8 to 9 would be the answer. 8 and 9 is basically 18 17, 17 to 8, so 8 will come, 8 will be low and 9 will be high, so 8 will check for 8, and obviously it won't be, when it is 8 it will be just 3 4 5 6 6 and 1 4, yes, so it will be also 3, so it will, the low will go to 9. So finally when low and high will be pointing towards 9, right? So it is low and high pointing towards 9, and when it is the case, so we'll just return, no, we cannot return, so yes, so high will be, so high will come, come back, because when we have already divided the array into two parts, we are trying to get something less than that, and when it is the case, then low and high will cross each other, and then low will always point to the part there, right? Am I going in the right direction? Yes, it is. So low, finally the low will contain the actual answer here, because high will be always less than that, right? So just return low, and here we have our solution. We'll just code it up. So let's code it up. So we have a low, that is something, and int high will have something, and what will be that is the main question. So here for sure the values are from 0 to 10 to the power 6, right? So we can make this as -1, because we have, we know that the array will contain something from 0 to 10 to the power 6, right? So if it is -1, that is the smallest element, that is just smallest element, there will be no elements in the nums array that will be -1. So we can do, what we can do is we just low equals to math dot max low and daily. Did I do it right? Yes, I did. So I have just told you that we have just discussed that the low will store, the low will be storing the max element, right? Max LE in the array, right? And this will, high will contain the all the sum of the elements, right? Sum of all the elements in the array, right? So low is here, and high will be plus equals to LE, right? So low and high is done. We'll just apply the binary search, right? While low less than equals to high, guys, you can see I am a little I basically comment a lot when I'm feeling good, so I commented this and I will try to comment more. There is little code and much more comment. Int mid equals to uh, low plus high, basic binary search. We'll just divide that into two parts, and what we need to check is written here. So we need to exactly divide the array in k parts, right? So there should be something. There should be something. Yes. So what should be the thing? Okay. So we need to find the required sum, right? The actual required sum. So sorry for that. Let's make this another method to calculate the required sum. Public boolean that will just return us true or false. So let's design it like this. So mm, 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 mm. So if it is less than equals to the if the temp k is less than equals to k, right? So if the temp k is less than equals to k, temp k, what is the temp k? Temp k is the required sum. So the required sum less than equals to k, right? So let's say we name this function as name this method as minimum required sum, right? Did that make sense? We're trying to find the minimum required sum, right? Maximize the minimum required sum, right? So let's say yes, it is okay. It doesn't make any sense. The naming is just fine. So we'll be having this array or num. We'll be having this int mid, and let's take k also. I don't know if we'll do something with the k. Obviously, it will be required. So yes, so this will be a little tricky because we haven't really discussed how to calculate the required sum, but I think we're good to go. I will just figure it out in a way. So firstly, what we'll do is firstly we need to loop through the array. That is for sure. We cannot have this type of array. Nums.length, right? Oh my god, I plus plus, this is the array, and we'll be having in temp k, right? So it will be 0. Will it be 0? It won't be 0 because for it will be 1, right? So you know for sure the temp k would be 1, right? Here, see, temp k would be 1. So at max we always be having at least one element, right? Okay, so we have one element obviously. So every time, so at least one particular array will always come, right? So the temp k will start from 1. Okay, that makes sense. Okay, now what we need to do is we have our mid here, and we need to count sum, right? Required sum that is count sum, right? That will start from 0, and we'll just count sum equals plus equals to the nums I, right? Now we need to check, right? We have just sum it up, but we have to check that it is if it is less than equals to k, not k, mid, right? So we'll just check if I'm sorry we'll just check if nums count sum less than equals to k. Did I do it right? Just doing everything wrong here. Okay, so just trying to do something, I don't know. Okay, just we'll just comment it so we can understood. So we're just summing it up. Every time we sum it up and we check if the count sum less than equals to mid, then we know for sure that uh, we'll have to increase the temp k, right? We'll have to increase the temp k, and also count sum equals to num sign, because let's say we have 5, right? Not 5, we'll just take something greater than that. So let's say we have 7, 8, let's say we have 8. So first 1 is there, so 1 comes in there, 1 comes in there, and we check 1 less than mid, 1 less than 5, 1 less than, what did we choose? What did we choose? 8, right? 1 less than equals to 8, it is right. 2 and 3, 6 less than 8, it is 6 less than equals to 8, right? Then 10 less than equals to 8, no, it is not. So when 10 less than equals to it is not the right thing. Greater than equals to mid, that should be the goal. So count greater than equals to mid, right? That is the thing. So if count sum greater than equals to mid, then we increase the temp k plus plus, and we'll store the normal value, the particular value into the array, in the count sum, right? Are we doing it right? Let me see once. Yeah, so 1 2 3 we have got, and we have uh, how much sum did we have? 3 4 6 6 and 10. So when we have 10, this condition will satisfy. Temp k plus plus temp k will change to 2, and count sum equals to count sum equals to nums I, that will be 4, right? Yeah, so we'll start from here now. So it is right. So count sum will be 4, and again 5 will come, and after 5 will come, what will be the scenario then? So 9, that is greater than 8. So when there is greater than 8, you know for sure it will again increase the temp count to 2, not 2, it will be 3. Count sum equals to nums I, right? And finally we have count sum equals to 3, right? It is working fine. Can we do something like this? Okay, we can do something like this, right? Don't need to, this is just working fine. So lastly we just check return. Also, for example, if we are sure here that if the temp k is basically less than equals to k, if that is the case here, or equals to k, you know for sure it will be true, right? Return true, right? Okay, so for example, yes, so let's say we have 8, and when it is 8, this will be 1, this will be 2, and when it will be 2, it will check, and it will return true. That's what we want, right? We want to check less than equals to k. So we don't need to check for 5 also, right? When it will be a very big array, then this complexity will add up to it, and it will make it then it will just make it unoptimal, a little unoptimal. So lastly we'll have to just return basic thing, temp less than equals to k. Yeah, so now we just check if did I do it right. We did. So if yeah, just having a hard time right now. I didn't sleep last night, but yeah, I'm trying to focus. Yeah, so what we need to do is we need to check that the temp k greater the we have just figured it out, right? So if it is the case, we just minimum required sum, we just pass this minimum required sum. We'll just pass firstly the nums array, the mid and k, right? If it is true, we know for sure that low equals to not low, high equals to mid minus 1, right? Else we know for sure that low should be mid plus 1, right? Lastly, we have just figured it out. We need to return low. I think it should work. If not, I would just die. This is the first hard problem that I'm trying. The first LeetCode hard. Let's see. What happened? Where is return temp? Temp. Oh my god, this should be temp k. Let's try it again. Acceptance rate is 58.2%. Oh my god, what happened? Um, it is 10 and this is 5. Why is it though? Did I do something wrong? I'm very sure it is because of this function. Because this I did right only. Um, mm, 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 mm. Let's do it for 15 then. Um, let's do it for 15 then. So it is one. It is 1, 2, 3, 4, and when it is 15, right? So let's say if it is 15. So for the last element, it will go here. For int equals to 0, count plus equals to that number, and greater than equals to mid, right? If it is the case, then we'll just increase temp k plus plus. That is wrong here because we cannot increase the temp k plus plus there. I think that is the thing that I've done wrong, because when it is 15, then we cannot just have two arrays, right? It is just making this split into two arrays. We cannot do that. Let's say if we just delete it, right? Let's say if we just make it 0, right? And we'll check again. Let's say we'll check for 8. Firstly we'll check for 6 and then 15, right? So let's check it for 6. So it is 1, this 2, 3, 6. When it is 6, high equals to mid, this will come, and then count sum plus equals to num psi, it will be 6, and count sum greater than equals to mid, so it is 6. Temp will go to 1. First perfect, this is perfect. Then count sum equals to num psi, that will be storing okay, all right. There is this problem, we have just figured it out. All right, we just figured it out. Firstly, if it is 6, right? If it is 6, we cannot have more than that, right? We cannot have more than that, not equals to that. We have just figured out this. So let's do it again. So it is 6. Is it greater than 6? No. Is it less than 6? Yes. So when it is less than 6, we do nothing. We'll just check k equals to true, not true. Then we'll just go to the next. 6 plus 4 is 10, and obviously it will fall into this condition, and temp k plus plus would be just increased, and then we'll just get something like 4 into the array. 4 greater than mid? No. 4 and 5 greater than mid? Yes, obviously 9 greater than mid. So it will, lastly it will store 9 into it, and we need to check again, I guess. That is the thing, we need to check again. We need to check again here that if count sum greater than 0, then we need to k temp k plus plus. Did I hard code this part? I don't know, but yeah, let's check for 15 then. So let's say we have these elements, and this is uh, mm, how much this is, oh my god, 10, right? So 10, when it is 10, doesn't matter. If it is 15, we lastly go here, if count greater than mid, right? Yeah, oh my god, right, right. So last time when it will be, so it will check, and if it is 15, temp k plus plus, it won't satisfy this, and it will check here, and it will come here, and then it will make it 1, and it will just return. I think I've done it right. Let's check it once. Still not right. Something is wrong. Let's see if I had output 5. How can 5 be a possible answer? Doesn't make any sense. So let's say if it is 5, so 1 and 2 3, and it is 6, so 1 and 2 is 1, 3 and 4 would be 3 would be 1, 4 would be 1. That's the case, right? If, oh my god, what I've just written here. If temp k equals to k, right? We cannot do that here. It just make it just make no sense here. There is a possibility that if temp k equals to k, right? There can be a situation where temp will just be greater than k, right? And we know for sure that we don't know that, so we just check here that it is greater than k or not. If it is greater than k, then we are sure that it would be false. Other than that, we cannot say what is happening in the array. Oh my god, I think just rule out every possibility. So, oh my god, yes, I think I have to see a little bit whether this part can be changed into something else, because this is just crazy how I've just written this code. This doesn't make any sense. This can be just optimized. Let's try to optimize it. Let's try to make it a little prettier. This is just shit. Okay, just bring it down. We can make it 0. I'm sure. Hmm. Yeah, I think it is good. What happened, bro? I'll have to check, bro. I'll have to check. Let's be it like this. I'll take that. I'll take that. I'll take that. Whatever it is, I'll take that. I'll just solve the problem. Oh my god, 1%. Oh my god. Did it, bro. First hard problem. Solved it. Analyze complexity, that will be obviously big of log sum minus max. Let's see it once. Oh, also, yes, I just forgot. N would be n would be the time that will be taking to do this, right? I was just thinking it. Yes, so this is the time. So in that case, in this case, it won't be there like this. So it will be just n into this, right? Yep. So just did it. Oh my god. Let's see the solution. What did they do? What they did the same thing, right? Required some array, some plus. They did the same thing. Oh my god. Wait a minute. How the hell how the hell did the solution is 0% of runtime and my solution is 1% of runtime? Are they crazy or what? Did I do something wrong? I didn't check this functionality, right? I just said that, but I didn't did that. I haven't done that part. Should we do that? We should do that. So we know for sure that if nums.length equals to k, so let's check. So if nums.length equals to k, return low, because low will be if nums dot if just uh, so all elements, if k equals to 1, right? K equals to 1, then return max, that is high. I think it should work. Let's see. Submit. Para pum pum, but it doesn't. Where is where is the problem, dude? Uh, this time complexity is making my head a little bit spin, but yeah. What did I do, man? What did he do? What did he do? What did he do? He didn't break from here. He didn't do anything else. This is just crazy. If nums equals to null, k equals to 0, nums.length equals to 0. That is just dumb. They have just, oh my god, that is just so dumb. They have just said all of this, that nums.length should be in the range 1 to 1000, and man, he has just written nums equals to null. How dumb can someone be? K equals to 0. K cannot be 0, man. K is between 1 and min 50 dot nums length, right? And nums length also cannot be 0. It is just stated here that it should be between 1 to 1000. Oh my god. How are they? Did I do something wrong? I have just did the same solution, but it is taking a little more time than them. Why is it so? I don't know. I don't know. Mm. Oh my god. Well, low less than equals to high, int mid low line. Trace mid tells low load mid plus 1. Doesn't make sense. Also, why did it required sub array? It's 1. He made it 1. Hmm. Required sub array like equals to k. He just did it the other way around. To count some. If some temp k plus plus comes from nums I sums plus equals to I sums greater than it. I did the same thing. Temp k plus plus sums equals to a plus I. The same thing. Also, I did check that if temp k greater than k, this should this should bro this should what the what the hell, dude? Yeah, whatever it is. I am damn sure that there is some problem with this. There is some problem with this summation thing because I did everything right. Don't tell me it is because of this. Just because he added this thing doesn't make any change. Doesn't make any sense. Let's see. So what it did is low plus high minus low. I did because it will just cut out low plus high minus low. So it will be just high minus low and low plus. It won't overflow, dude. It won't overflow at all because it is 10 to the power 6 minus 9. I don't know. There is some problem with this. I'm damn sure. Let's change it to the normal solution here. That was earlier, right? 0 ms of time. Wow. Wow. 0 ms of time. Why isn't it mine? Because I have done something wrong, which I cannot figure it out, or it may be something related to this shitty thing. I've just done everything right. Oh my god, this shit. I'm happy that I'm able to solve it. Java.lang.math. Oh my god, you don't need to do it because it is obviously included. Java.lang.math is already included in it. You don't need to import this kind of shit, but I don't know. Yeah, it is just the problem of this compiler, I guess. But yeah, whatever it is, I'll take that. Don't tell me because of all this. Nah, it shouldn't be the case. Okay, whatever it is, we have solved it. We have solved the first hard problem in our we have solved the first hard problem, guys, and it goes up to 60%. Sorry, we have completed 60 problems, and there is uh, some summations here that I've done. I'm trying to be a little consistent, and the medium count is getting higher a little bit, right? And obviously, as you can see, 59.32 percentage. I don't know what is the problem here. Anybody who is watching, let me know whether you guys have figured out anything or is the solution. You can just go to my account, right? LeetCode.amsp and see the solution here and tell me whether I have missed something, right? Or whether it is because of anything else. I cannot figure it out, right? Just tell me. That is it. If you have seen this until this time, thank you so much. I'll meet you some other day with another problem. And this problem is solved, and we have done 20 percentage, right? And 20 percentage, 90 problems done. Enough. Let's keep going. Okay, so we'll just take your leave then. Bye bye.